Chazlarge here with yet another Fix It video for you, and on the bench today we have got this Denon mini hi-fi. It's a CD player, radio, USB iPod player, portable input, and also the usual array of auxiliary inputs and outputs on the back here, also subwoofer output. It's got an FM and I believe it's DAB radio as well. I'm not 100% sure. No, it's just ordinary FM radio with RDS. I thought it was DAB, but not to worry, that's a different model altogether. But it's a model number RCD M38. The reason the top's off is basically I just really wanted to check inside, make sure there was nothing floating about, because it arrived in packaging which was okay. Let's just leave it at that. Anyway, I've plugged it in and tested it, and the fault as described is present. Let's just apply the power, and we've got no standby light coming on to start with, so there's no light coming on. I believe that these should have like a red light as soon as you apply power. This power button, which is not a main switch, it's a standby switch, but when you switch it on, there is a click from the relay. The red light flashes like so, and that's all it does, is the red light flashes. I believe it's supposed to go green, and it won't turn off either. So let's just unplug it again, just in case I didn't quite catch if there was a green flash. Right, so obviously the power supply is a bit fully charged up. Let's power it like that. It may clear it down as such. Try again. No. Oh, there we go. And then we had a green light for a few seconds, and then a red light, and the relays clicked off again. So that says to me that there is a problem either with the power supply, which is in this area here, or with the sound output stage. It could well be that the sound output stage is effectively dead, causing the power supply to be dragged down. So we need to see if we can get a manual for this and have a look inside. We've got luckily quite a bit of area here that we can test various voltages, but I have worked on a couple of these before, and they're a little bit difficult to work on because difficult to get at things whilst it's all together. Sometimes you have to really sort of splay it all apart. The output stage, by the way, is quite a substantial output stage, and it's on the side here with these big heatsink, so it could well be that one of the output transistors has died for whatever reason. There could be shorts and so on, so it's going to be quite an interesting little investigation. So let me see if I can get a manual for it. Right, well, luckily I managed to find a service manual for it, and going into the power supply we can see that we've got quite a nice little power supply here with transformer, various regulators, and we've got a single output connector with various voltages on there, and we've got a plus 5 volts, a power on line, a power down line, and a standby 3 volts. So they're all available on this particular connector just here, and I've got my meter set up here, so we're going to try this, and luckily they're all actually marked anyway, so even if I didn't have the manual, hopefully I would have been able to see them. So we're looking at pin 5, which is this one. It says plus 8 volts, then ground, power on, power down, and standby. Okay, so we're going to check these voltages in turn. So let's see if we've got to start off with a standby 3 volts, which should be on there. Got power applied, and we've got 3.8 volts, and that one there should be 8 volts. Now, does that come up when I power it on? No, it doesn't. Does that one change? Power on, power down. They seem to be sort of floating. That one's definitely 3 volts there. That's 3 volts there. So we are missing our plus 8 volt rail. Right, well, having got the manual out and looked at it and spent a little bit of time going through this, the problem is that the way that this works, and this power supply that we've got here on here is actually just the standby power supply. Effectively what we've got is mains in through a little transformer, bridge rectifier, and provides a output voltage here, which we've got. That then feeds the main control, so when you press the power button it switches on the relay here, and that relay then energizes the transformer in the rest of the power supply, which then feeds this little lot up here. And you can see that if we actually have a look at the block diagram, and you can see effectively the same sort of thing. It's not all that clear from the block diagram. You've got over here, you've got the mains input, and it just says mains transformer, DC to DC converter for the USB. Well, basically you've got a supply rail coming into here, supplies this MCU, that then feeds back when you press the power button, and then that turns on the rest of these supplies. So what we really need to look at is the rest of these supplies when we switch it on, because we know it is switching on, and we know that we can see the light comes on and goes off again. So what I'm pretty sure is that one of these supply rails here is the cause of the problem. So it's not this bit here, which is basically the standby supply, the main power supply. So let's see if we can do that. It shouldn't be too difficult. I'm pretty sure I've had something similar to this apart before. I think the first thing we need to do on this, to get this CD player out, if you've ever had to work on one of these, basically you've got to take this front panel off. So if we just gently get hold of this volume control knob, and it just needs a good grip and a pull. And then we've got inside there a fairly standard screw nut. Unfortunately, the rest of the power supply connections are not that easily visible, so we really have to get the CD player out. Now before you go any further, the next thing you've got to do is to remove the CD drawer front, and to do that we need to crank the CD mechanism out. If my memory serves me correctly, you should be able to reach the drive somewhere in here to do it manually. I can't remember exactly where it is. I think you have to take this plate off the top here, and then that's the clamp plate, and then I think you can get your fingers under there, if memory serves me. Could be wrong, but I seem to remember that. Yeah, there we go. So once you release the clamp, there's this gear wheel here, which you can just gently turn around, and then you can release the tray, and then you can just lift off the little plastic bit at the front, push the tray back, and now the front panel should come away. I don't think there's any hidden screws there. No. We've got all, perhaps we just didn't release all the clips. I did, but they clipped themselves back in again. comes away. Okay, I may have got this wrong. Maybe we just, I thought there was, to be honest, I thought there was hidden screws behind this plate. I may be wrong. I just seem to remember them being some hidden screws under that plate. In which case, if I'm wrong, I'm thinking of the wrong machine. It happens. Yep, I'm wrong. So we don't need to remove that plate from there at all. I apologise for confusing you. Alright, so we've got it that far out. We can actually put those screws back in there. Silly Millie, never mind, let's pop those back in there. I think the silver ones down below, we do have to release those. Yeah, so it's just the side ones and the bottom ones then. So once we get that far, that's just gives us enough movement. I think if necessary we unplug the front panel from that point, but we've got a ribbon cable down here to be aware of. So we should now be able to release the screws holding the CD mechanism in. Now either somebody else has been in here, which I think is quite a good possibility because there's only one screw. So somebody else has been in this before I got it, and they've left several of the screws out. How nice of them. Never mind, I've got a box of spare screws, we can always fit spare screws back. Alright, so we can unplug the CD player. We don't need to have that in. Let's grab my... Ah, and there's also a cable hanging off down there. That should be plugged in down there. Yeah, definitely somebody's been in here. They're little beasties, aren't they? So that plug being unplugged would tend to indicate that they've got so far we're trying to fix this and couldn't. Let's plug that front panel in and see what happens. See if it does anything different, having found that plug unplugged. It looks exactly the same, but at least the red light is just still flashing. Okay, so let's get back in there again and see what's going on. Let's unplug the CD player. Now the rest of the power supply is down here, I'm pretty sure. So along down this side we should be able to see. We need to reconnect the front panel, unfortunately. Don't think it relies on the CD player being functional for the power supplies to come up, but we should be able to see, and we can in fact see now. If we look down here, we've got supply rail itemized. So we've got AC 3 volts, which is the fluorescent display. We've got the higher voltage for the grids, and we've got plus 12, minus 12, ground, switch 5 volts, and another AC 15 volts. So we should be able to test those with a test meter and see which one of those, if any of them, come up or don't. Okay, so this here is the input from the transformer when it's switched on. So So we should have AC 15 volts, which is down the bottom, and then we should have, these are all AC voltages coming in. Let's just see, AC 3.5, yeah, so the AC 15 volts is on there, so we'll put the meter onto AC voltages and we'll switch on. Now we should have no volts there until we switch on. It's interesting, it says plus 12 volts, which is pin the last but one. AC 15 volts on the top one. There's nothing there. Make sure I'm on a good ground. Definitely should be seeing AC voltage on this first top pin there. The sub power supply, the main transformer there. We are getting AC mains voltage going into there. Yep, 240 volts going into there. So we're getting 240 volts going out of the sub transformer. Right, I'm just going to stop this for a second while I just double check where I am connector wise. Right, well here's a weird thing. When I wanted to see, this is the output supposedly from this relay, when you put power in, that relay is turned on by the standby switch, and that then provides power to the mains transformer. This is the sub transformer, this is the mains transformer here. But I was getting AC volts here all the time. I then thought, well, if we get an AC volts there and we're getting nothing out here, which is the AC from the transformer there, and this is on all the time, irrespective of the electronic switching, there must be something wrong with the transformer. So, meter on ohms, across the transformer primary, nothing. Transformer's open circuit. That's what it looks like anyway. Now, it's possible that this transformer's got a thermal fuse in it. So let's see if we can have a look at the underside. It's curious as to why there's volts here and there shouldn't be. That should only come when that relay is turned on. Has somebody inadvertently gone underneath there, because we know somebody else has been in this? Has somebody already bypassed that relay with a short circuit in their fault finding efforts? So it could well be that they've discovered that the transformer's open circuit, and so consequently given up on it. Interesting, that one's threaded, that one wasn't. This AC input socket. And there's another screw here, this bracket. So in theory this little circuit board should come away on its Todd. There's no connections to anything else apart from a bit of goo. Well, if there is a thermal fuse in there, I ain't going to be able to dig it out. Right, one other test we can do. So we should be able to see on pin 6 of this connector here, it's weird, hang on, no, that's the AC input down there. This is the output to there. The AC output from the transformer is those pins down there. I think so that we can double check everything, we need to strip this right back. So sometimes you can see on a transformer there's like a little piece of plastic standing out, but that transformer is definitely open circuit as far as I'm concerned. So I'm going to see if I can get hold of a replacement transformer. Got part numbers on it, so hopefully this part number will come up with something. Failing that, another old scrap Denon that might be doing something. Be a shame to lose it all, but anyway, got a mountain of spare parts. At the end of the day, can't do it. So, see what I can find. We're back with this Denon M38 and the transformer is there. Now, I dug into here and managed to find where the connections were for the thermal fuse, and sure enough the thermal fuse had actually gone open circuit. So doing a little bit of pulling about, cutting a bit of plastic, I managed to find the two ends and short them together so that the transformer still works. So hopefully that may help lead to the problem, and it does in a way. I left it running, it did actually power up, and then the fuse popped and I thought, okay, something's wrong. Felt the transformer really hot. Now either the transformer is at fault or there's a fault with one of the power circuits somewhere in here, and so I thought, right, let's put it to one side and let's see if we can actually find this transformer. I had actually instigated a search. As luck would have it, somebody managed to have one of these for the M38, and it is exactly the same transformer. It looks possibly like it's either new old stock or it's been recovered from a faulty unit. It's just got some tape with some sticky stuff holding the things together, but honestly it doesn't look like it's an old transformer. So the thing that I'm going to check first and foremost is the resistance of the secondaries on this compared to the resistance of the secondaries on this one, to hopefully see that if this transformer is at fault, there'll be a difference in the winding values. May only be tiny, but if it's significantly tiny change, then I know the transformer is at fault. If not, then we know the fault is still somewhere else. Had lots of other things to do, so I couldn't investigate other things, but I did check out the main bridge rectifier and circuitry here, and that's all working okay. I still suspect that the fault is here in the audio amplifier output stage. So let's just get this transformer back out of here and compare it with this one. Okay, I've got the two transformers, just undone the wrapping on this one. I think this one may be an original transformer that's perhaps been taken apart and the fuse been replaced, because there's a label covering up the original manufacturer's label with a warranty seal on there. So it could well be that this transformer was a second-hand one, and the thermal fuse had failed in it, so they've taken it apart and replaced it. Doesn't say that, it just says new transformer. Anyway, we'll wait and see. So I'm not going to check the resistance of the primary. I'm pretty sure that's probably going to be okay, but I will be checking the secondaries. I'm going to say that transformer's probably okay. I think if we had a shorted turn in those windings, it would have really shown up as a 0, because that's what short turns do, unless it does it when it gets hot. I don't want to put this in yet until I've proved that there is a fault elsewhere, so I'm going to put this new transformer to one side. Let's have a look at the circuit and see what that actually shows in terms of the power supply. Now the power supply is all over the place on this because there's multiple supplies, but I'm going to look at the audio output stage, because when I shorted out the fuse on the transformer, the thermal fuse, powered it up, we got a display. So I'm pretty sure that the power supply to the system controller is all working. The only power supply that it wasn't working was the one to the sound output stage. So either the sound output stage is at fault or something feeding it. So if we have a look at the circuit, we can see, try and work out where all the power supplies go. So we've got mains comes into this power supply here and comes out of here as a standby 3 volts through this regulator. Now we know that that was okay, so we could just put the transformer back into here, connect up just this board and see that we get that and that the transformer doesn't get hot. That's going to be our starting point. So once we've proved that this little bit, I mean, it's not going to be switching on and off, because these other supply rails aren't going to switch until that board's working, but at least we can prove that that's there and that the power supply, this bit here, is not causing the transformer to overheat. Now the one thing that I did notice is that this relay, this power switch relay, did actually switch on by itself. I'm not too sure why that is, whether that's normally closed and then it's switched off once it's on. Anyway, we'll have to work that one out. So let's connect this bit's of circuit. I may be able to do this all actually, in fact, separately. So right, so this is the little sub power supply. I'm just going to see if I can just pop that into there. I should now be able to put my meter into these 2 connections like that. If we switch it on, we should see if there's AC getting to the transformer as soon as we've high power. And there's not. There's AC floating about, but there doesn't appear to be AC getting to the transformer, and that's because that relay is open, isn't it? It's normally open. So I'll click that for a minute. Let's just double check that with our meter. So mains comes into here, live comes into here, goes to there, through the relay, which is yeah, that's the relay connections 2 and 3. So we're on ohms at the moment, so ohms gets to there. We've got a dead short, and then if we go to there, it's open because that, and then that goes through, once it's gone through the relay, it goes through this fuse, and then from the fuse through these links to that. So we should be able to bypass this relay, so that we'll be able to supply raw mains into here and up to the transformer. Okay, so we've temporarily shorted out the relay, so let's reconnect the mains cable. It's not plugged in at the socket, so I'm safe. And we can plug the transformer in, and we can just switch it on at that, and if the transformer starts buzzing or gets hot and the smoke comes out, we'll know the transformer's at fault. So here we go. I can do spot temperature checks. It's only 23 degrees. Right, switch it on. .1. Let's just turn it off and just feel it for a minute. Yep, okay. So we've still got no change in temperature in this transformer. I'm pretty sure the transformer's okay. So we should now be able to plug in this subboard. Move the live mains bit over there. And on the subboard, we've got two regulators, IC92 and IC94, 5 volts and 12 volt outputs. Let's see, on this connector, CN73, which is this one here, isn't it? 12 volts, 8 volts, ground, and 14. So I should be able to easily measure those. Right, I've hung a bit of wire on this so we know that is definitely ground. And in fact, it's a bit easy, it's going to actually be a bit easier to work on this if it's upside down, because we can actually see the pins a lot easier. So my ground is connected to my meter. We're on volts mode. I'm going to do all this one at a time, switching it on and off carefully each time. I don't need the specs on at the moment. So we should have 14.2 volts on this pin. Plug it in. Oh, 31 volts. That's not good. And pin 5 should be 12 volts. Shot up to 9 volts and then drop back down again. Let's do that one more time. 9 volts. And then drop back down, but that, I'm a bit concerned about this 14.2 volts going to 30 volts. 32 volts. Now that may be 32 volts with no load. Let's have a look at the circuit. So that should be 14 volts there, and we're getting 32 volts. Okay, at this particular point I decided to stop this video and do a bit of an explanation, because the amplifier here has got so many interconnections between different boards. It became almost impossible to keep track of where the voltages were and where bits and pieces were in fact together. So I found that the earth, by not connecting the boards together or in the chassis,
stopped the earth from working properly, so therefore voltage readings were a bit incorrect. I found that the main supply rail that went down to the audio output stage was low because of the connections and the bad readings. I had to really basically link all the boards together and found that the output stage itself was at fault. So I'm going to cut to the point now where I've identified that the audio output stage is at fault and where it's taking down the supply rail to that, and I'll show you how I disconnected that and proved that it was actually the audio output integrated circuit that was the cause.
We're all connected up, ready to go, so we should see, if everything's working correctly, we should see plus 22 volts come up here, and we do plus 32 and minus on there, minus 32. We heard a click. There's nothing on the display yet. Heard a click, still nothing on the display, but I'm pretty sure that everything's going to be okay once we replace that. I haven't got the CD mechanism in, but I may have left another wire off somewhere. But anyway, the supply rails are coming up now, so that IC is going to be the cause of the problem. Just quickly fill this transformer. Yeah, it's no warmer than it was before. After all that, it's just the IC, and I should have known that and should have gone for that beginning. Never mind, I'll come back after I have got a new IC. Okay, having fully reassembled it, making sure that everything I've soldered, unsoldered, has been reconnected, everything apart from the output IC. I'm hoping, fingers crossed, that when I plug this in now and power it up, we're not switched on there, we're not switched on there, plug it in, power it up, it should come up with a display. I've even put the CD player in, and it should do everything apart from give us sound. Have a click, we've got tuner, we've got tuner display. Let's eject the CD, go to source, so we are nearly fixed. All we've got to do is get one of these ICs, an STK 433-040. Fingers crossed we can get one, and then that'll complete the job. It's dead easy to get this amplifier board out. Just a couple of screws down here, unplug a few things, the whole lot lifts out. Dead easy to replace. So I'll come back to you once I've got that chip, and we should be okay. Fingers crossed. Well, here we are back with this Denon M38, where we diagnosed previously that the mains transformer had blown a fuse, and then after a lot of fiddling about, trying to identify where the power supply had failed, we ended up with the audio output chip had failed. Removing that, everything else appears to work apart from not getting any sound. So we placed an order, and thanks to Little Diode, let me just put that on the camera there, Little Diode, one of a list of suppliers that I use for spare parts. Get them on eBay or littlediode.com. You can get spare parts, and they've supplied me with a genuine original output integrated circuit. I've never been let down by Little Diode, so if this works okay, many thanks. If it doesn't, you'll be hearing from me. No, I'm sure it'll be fine. I'm sure it'll be fine. I'm just a pessimistic old goat, and I do have a tendency to look on the dark side of things, especially with all the years I've been doing this sort of thing, and then being disappointed by not getting spare parts. Thankfully, this output amplifier section comes out quite easily. all we need to do, if you ever have one of these and you suspect this output stage, all you have to do is undo the screws, and you may notice that I've put some markings on here, because that's to point out that there are screws underneath as well. So you need to undo these screws at the bottom, and these are round headed screws or oval headed screws, and these go into the heatsink. And then there's these two screws, which are countersunk type screws that go in the side, and they're all self tappers. So now we should be able to unplug all the plugs like so. This one from here, this one from here, and of course the dreaded one that I forgot about is a plug that goes down underneath the optical, underneath the CD unit. So you actually do need to take the CD unit out to do this. 4 screws on there. I wish I'd have left that one out, but I didn't. So, well, I was testing it, so there was a genuine reason for doing that. So let's separate these screws. That's the ones for the amplifier. This is the ones for the CD unit. CD unit comes out reasonably easily. Just those 4 screws there, and then the CD unit lifts. As long as you've got the front panel off, you may need at times to eject that to get that out. And so there's the plug that I should have left out. It's plugged in there to that audio stage. So we can just lay the CD unit back in temporarily. We don't need to disconnect it, take it out, because all we want out of here is the audio output stage, which should now... Oh no, we've got 2 plugs down the side here as well, haven't we? Ah, yes, I'd forgotten that one as well. Hopefully I can just lever that one out with a pair of pliers. And a screwdriver just to get the bottom part of the plug out. There it is there. It should be able to be pushed in once we've got the amp out. No, we've also got that plug there, which goes onto this side panel here as well. I do hate pulling things out by the wires, but in this case it's the only way to do it. And that should be it. Nearly there. Just a little bit of jiggling. So there we have it out. And the IC goes in there. So the first thing I'm going to do is just to clean off the old heatsink compound on here and apply some nice new fresh heatsink compound. Simplest way of getting that off, first off with a piece of kitchen roll. Right, having got rid of that, let's get some fresh heatsink compound. I think that should be more than enough to coat this area of the IC. A little tad more just on there. And that should now locate the pins into the holes first. There we are. That's in there. These are the two original screws that held it in place. Make sure the holes are lined up. Just do a little bit on each one because it's got to squash that heatsink compound down, but you don't want to over tighten this in case you crack the plastic housing. So I'm just doing this up finger tight with just an extra little twist, and that should do it. Jolly good. Soldering iron, solder, and away we go. Put those two together as well. I'm getting worse in my old age. I really am. Suppose I should have flooded it with flux. That's what everyone's probably shouting at the screen. I'm using flux solder. It's so shiny, it's very difficult to actually make sure that I've got everything. Oh, I've done it again. Blobby, blobby, blobby. I'm the original Mr. Blobby today. Come on, what's the matter with you? Right. Give it a clean off with some ISO on a toothbrush. Wondering whether these pins have got some sort of lacquer on them. It's just, they just don't look like they're soldered all that well. Yeah, that looks good. Let's give it another little clean. As a final check, we'll just go through in between the pins with my point. There's a white PCB marking in between the pins, which I should show clear. Okay. Still not happy with that third pin. Just one tiny little touch more on that third pin, because I'm not 100% happy with it. Yeah, that's better. In fact, the second pin's... Yep. Okay. That's done. As far as I'm concerned, that is soldered in good and proper. Now this big wire, we can actually plug this wire in before we put it back in, which will save a fair bit of time. Should be able to just jiggle it down. So we don't trap anything we shouldn't be trapping. Catching something. Lift the optics out for a minute. There we go. That one's in there. That one's in there. And that one's in there. So I think we'll just put the little countersunk screws in the side for now, just to make sure it's got a good solid connection to the chassis. We'll worry about the screws for the CD mechanism later. Tidy tools. Connect speakers. White is right. Before we plug that in, just a quick triple check that we have plugged everything back in that needs to be plugged in. Yep, seems to be. Power it in. Switch it on. Tuner comes on. No output. I think that's because it's got a muting on it. Let's try CD. It's not blown any fuses. Yay! It's working! That's useful, isn't it? Very useful indeed. Very happy with that. I knew the CD was working okay. Let's just check the radio. I know the radio did work, but let's put some music on USB. Right, just transferred some music into a USB, and it says route 11 tracks, play. Yep, sounds pretty good, and I've got new speakers up there as well to test it with, so I'll just show you in case you really want to have a look. It's a pair of second-hand JVC speakers, replacing the old crappy speakers that I had up there that I blew up with another amplifier not so long ago. Well, didn't blow them up, I overdrove them, let's put it like that. So we seem to be working on all features. I just need to remember how to tune this in, but I'm not that bothered. The fact that it's doing everything that it should do is absolutely fine. The amplifier is now back to normal. We diagnosed it was the output stage, which was blowing the fuse, and took out the transformer. Now I'm going to leave the old transformer in there, having wired it, and give it a good test. See if it does overheat or anything like that. I'll keep a monitor on the temperature, but I'm pretty sure that that's going to be okay. It's only going to be used for testing purposes in here. It's not going to be sold on. It's just something I picked up second hand off eBay. I thought I'd just give it a go, and it might make a nice video as well, and it did. So that's it. Hope you've enjoyed this little video. Thanks very much for watching. I'll see you on the next one. Cheerio.